Before we nail down the core functionality of our happy app, let's try and understand how it works in the first place. This will help you understand the code bits better. When you press the process button, the studentdata.json file is read in and via the Stomp client module published to a queue called toPython. As the Python script on the other end receives this data and starts processing, it keeps publishing back objects containing the student name, course name, and the file name of the image that it has generated. As this data comes back on a queue called from Python, it gets pushed into the item array. As this happens, we will use ES7's array.observe method to asynchronously watch this array for changes. So the moment an object is pushed into this array, we will emit it as an event using socket.io to our web page where it will be displayed in real time. Data comes back as objects with 3 keys: student name, which refers to the name of the student, the course name, and the file name. Keep a mental note of this for now. In terms of execution, once the Stomp client connects, we will first subscribe to a queue called from Python because this will be the channel over which the processed data will come back from our Python script. Also, once the Stomp client successfully connects, we will establish a socket.io connection to the page. Then, when the user presses the button, we will publish our data to Apollo and follow the rest of the process as described earlier. Now, normally, this means that all our socket.io code will be nested inside the callback for the Stomp client's connect method. But instead of getting into a nested callback, we will use promises. An asynchronous function implemented using promises can return either a resolved state where what the function has promised to provide is fulfilled, or it can return a rejected state if it fails to do what it promised, such as in the case of an error. All the promise cares about is a fulfilled or a rejected state. In either situation, a promise is set to be pending till it is either resolved or rejected, and settled when it is done with either a resolved or a rejected state. Promises help you detangle your code, especially when you run into callbacks inside callbacks, also known as callback hell. Though in this example there isn't a callback hell per se, I will still use this case to demonstrate promises. Till now, promises were only available using third-party modules like Bluebird, RSVP, or Q. But with ES6, this is natively available in JavaScript. Promises can also allow you to organize your code to either run sequentially or in parallel. So coming back to our app, we will turn our Stomp client's connect method into a promisified function so that it returns an instance of the connected client in a resolved state or returns the error that we can catch in a rejected state. This way, we can sequentially chain in our socket.io code to the resolved promise so that it can get the instance of the connected client and can use it when we have to publish data. On the other hand, the rejected state will bubble up the error from the Stomp client so that we can catch and display it on the console or log to a file. Now, this won't be a comprehensive case in promises, but will give you a taste of the way you can use it natively with ES6. So, with that said, let's jump back into code.